Recently, I've learned that when learning a programming language, one of the methods you can use is to just create something very simple, like, for example, say a quiz app, and make it more complex step by step. For example, we could have a quiz app like this: answer one, and we ask a question or we prompt the user. Answer two, three. So we can make them different questions, and we can say if answer one equals the result, which is two, we want to say result plus equals one. And of course, we have to create the result here. And let's copy this again and again. Then we have to say answer 2 if it is equal to 3, and answer 3 is equal to 4. Now when we run our main.py file, if we answer everything correctly, we have to actually print the result, right? So now if we answer everything correctly, we should get 3. If we maybe mess up one question, we should get 2. So now this is what we call tutorial code, meaning you cannot actually take this code and push it into a production environment. Uh, so today I'm going to be showing you how we can take this simple code and make it into a production ready application. But we are not going to be adding any advanced features to it. We're just going to make our code more production ready. We're going to be making our code like those codes you see on GitHub, or maybe when people talk about design patterns and programming patterns, all of the stuff you might have heard and thought it was a complex thing, but it's actually very simple. And we're going to be taking our code, and we're going to be using a pattern called dependency injection, and we're going to be making our code better. Now it will become more complex, but it will be more scalable. Scalable means in the future, if we want to add a feature to it, we can just simply do it. It means that if more users use it, we can easily make it faster. So let's start. The first thing we want to do is we want to create a complete file structure. So I'm not going to be speaking about making this a Python package. So packaging it as Python. We're going to be just focused on the code. So the project structure is very simple. We have a source folder and we have a data folder. So the data folder will be used to store our data information that the app will need to run, and the source folder will be used to store all of our code. So what actually runs, okay? So in the code and the source folder, we should have a lib. Now this lib, it stands for library, and all our supporting uh, files will be in this lib. So supporting means, for example, when you create a quiz app, you might need a way to process or calculate the results, right? So it will have its own folder in the lib. So for calculations only, you might need a method of uh, displaying the results, and that should be uh, its own file called results show results, something like that. So all those supporting files will be located in the lib folder. So if we want to do this, we need an initial Python file or init file, followed and preceded, prefixed and suffixed by two underscores. So what is the function of this init.py file? When we make our code modular in Python, we need an init.py file to make it easier to work with. And now it might be difficult to explain this, but as our code starts growing and as we add more files, I'm going to show you exactly what this does. But for now, just put it there and forget it ever existed. In the source folder, outside the lib, we should have a main.py file. This main.py file represents the entry point of our application. So everything that runs because we are actually running the main.py file. Before we start coding, in the data folder, I want to create a questions.json folder. Now, why are we using JSON? The reason is that it is probably the best way to structure data. It's the best file for structuring. You could maybe create a Python file where you store static data, but using JSON, you will have more. For example, if you want to share this data with other developers, you don't need those developers to be running Python. If you're sending just, they could be running JavaScript, they could be running Python, they could be running Go, they could be running whatever they want, and they could get this file. So we're going to be using JSON. Plus, we want to learn more complex topics of Python. So we're going to be learning how we can read JSON. Let's start. So as always, opening a curly braces for JSON files, and we're going to be having a key called questions, which is an array or list in Python. So this list will contain the questions. So each question should have a value, which is what the question actually is. For example, this is 1 plus 1. And you should have an answer. And as its name indicates, this is just the answer for the value of the question. So let's create a couple of questions. So 3 questions. Let's change it to 2 and make it 3. Let's make it 3 and make it 4. So now we have the questions and we are ready to move on. So one thing you might have noticed is on all of my files, I'd like to have an empty space right here. This is one practice of clean code. And the reason is most of the time you might need to run this, read the file as text in your terminal, and it is a good idea to have an empty space or an empty line here so that when you do that, it is more formatted. You might not see the difference now, but it's good practice and I always like to do it. So now let's close our data folder because we're not going to be actually interacting with them much as we already have all the questions we need. Let's start from the main folder. So in the main.py file, we are creating a function called main, which is our entry function. So everything runs in our application because we are calling the main function. So we could just do everything globally and start typing like print something, but we are using this main to make our code more modular, meaning separated, and to make it more functional, meaning there's a design pattern called functional programming, which means just separating your code into different functions or methods or definitions that do different stuff. So the main function or definition here It will be our entry point, and it will do all the uh, code or all the processing for our quiz app to work. So let's start. First of all, we need uh, our questions, right? First, let's actually create our result. So when our app starts, the result should be 0. When uh, when stuff happens in the app, like when a user gets a question correct, we will increase or increment the value of the result, but we should start it from 0. Then we need our questions, and we now have to import our data from a JSON file into Python. And this is where our first complexity comes in. To do this, we're going to be creating a function called getQuestions. This function will not be from the main file, but instead it will be from lib, and we're going to be importing getQuestions. When we say lib, we are referring to this library here, and this .init file is the one that will export this getQuestions method. So in order for us to export this, we can just say uh, we can say from actually let's create the file here, gets questions.py. We can now say from dot get questions imports get questions. Obviously we haven't created this method here, so let's just create it here. Now in the init file, we are from the root, sorry, from the root of the directory of lib, we are choosing the get questions file, and from that we are importing the get questions method. Now, since we are doing this in the init file, it means that when we import the library, we automatically have this get questions definition or function automatically in the lib folder, so as a module. See, so that's why we needed init.py file. Let's close it now. uh, so we get questions. So how are we gonna get the questions? Simple. First thing we need to do is read question. So we have to read the questions file, and this is a function that we're going to be creating .py. So we need to import it, and if we use, since we are using a lib, sorry, an init file, we can just say from dot import read questions file. But we have to also declare it here. You have to say from dot read questions file import read questions file. Now we have access to this in here. Now we need to read the JSON from this file, and this might be actually tricky, but it's actually very simple. So the first thing we need to do is we need the current path of the project, which is pathlib. So let's import pathlib here. Import pathlib, which is a standard library in Python, so we don't need to install any extra external modules. Just say pathlib dot path dot, okay, which is a method, and dot resolve. This will give us our home directory, which is Python quiz simples complex. This is the folder name. So from there we simply get the file path. The file we're referring to is the questions.json here, by the way. So in order for us to do this, we need to import the OS module, which is the operating system interaction module. So os.path.join. So if you're coming from a JavaScript background, you should know path.join, which is just used to join multiple uh, paths. So meaning, for example, we from the current path, which is from the home directory, we join to it, or we go to the data folder, and from the data folder we read questions.json. So now we have the path of questions.json. This will return an absolute value for this file's path. Now that we have that, we just want to read it. We can use the open function to read the file path. Now that we have that, we can just say finally json.load and file. Of course, we have to import JSON here. So what this does is takes the file, which is this one, and it converts it from a JSON into an actual Python readable dictionary. So a dictionary in Python is like an object in JavaScript if you're coming from a background there. So now we have the data of the file. So basically we want to return it. So meaning here we have the data in the get questions uh, file. Now we have read the questions file. Finally, what we want to do is we want to say questions equals from the data. We want to take questions because from this folder we have this key called questions. So we are getting this value here. So now we have access to all the questions. So we just want to return. So now our code might look vague. So anytime you're writing code, you should strive to make it readable. So I've tried to make it as readable as possible by using readable or declarative names for variables and for functions. But I believe this could be a little misleading. So I'm gonna leave a comment. I'm gonna say data refers to, which is the variable, refers to the content of the JSON file containing the questions. So, uh, so you always have to comment parts of your code you think that is not descriptive enough. So I don't think this part is descriptive enough by its own, so I'm just leaving this comment. Now we are getting the questions and returning them, meaning we have them, the questions in the main.py file. So let's try to print out the questions, right? Source main.py. Let's print it out. We get an error. Okay, so in line 5. So module object is not callable, meaning we have not imported something correctly. So it says it's in line 5 of get questions. So it means here. So this is probably referring to this part right here. Uh, so module object is not callable. Let's see. Uh, okay, we should have this here. Let's try, actually, let's try to print something out from here. print data. So it's not actually being called, so it's not getting to the level. So I want to show you how to debug stuff like this. First of all, reading the full error message is very important. It's telling us that the error stack is starting from the main.py line 9, which is this one. It's when we call this here, and which it leads up to line 5, which is this when we call this get questions. So we are correctly importing it from the lib. Then this is the line it's referring to, and from the get questions we are get questions to pi line 5, which is this, and it's because we are using this and we are trying to import it, but it's not getting imported correctly. So let's try to say import from dot read questions file imports. Now let's try it again. Okay, so now we have the correct code displayed here. Okay, maybe my Python version doesn't support this feature. So no problem here. We could just use it this way. So when debugging errors, you always want to go through the stack and maybe look for something you've missed. Now, since we've done that, we have all the information we need. So we have the questions. So we can now close a big chunk of our files and we can continue on to the logic of our main file. So now that we have the questions, I would like to know the length of the questions, which we'll be using this later. So it's good to have this length, and which is a function that can provide you with the length of a list. And as you can see here, it is a list. Uh, let's continue. Now we want to ask the user the questions, right? So we're gonna say for question in questions. So this is just basically we are iterating over the questions, and for each question we're going to be doing something. First of all, I would like to get each value of the questions. So as you know, the question have a value and an answer, right? So the question's text will be a question dot value or implicit, and the question answer will be question answer. Okay, so value and we have an answer. So we're getting them. Instead of writing this code multiple times, we can just declare them up top here. So uh, we want to say results. Now we want to calculate the result. So how can we do that? So first, I want to create a file here in the lib. I want to call it handle questioning.py. So def, which is a function here, handle questioning. Now let's, as we did earlier, handle questioning imports handle questioning. So we're just adding it to our export stack or export file. So now that we have the handle questioning function into our export stack, we could use it in our main.py file. So what is the handle questioning file actually do? So it is very simple. So it does is basically it's first it asks for the user's response on the question. So it asks for an input, and I'm going to use a template. Okay, so if you precede a string with the f uh, keyword, you get a template. So in braces, we could just say question text, and question text, by the way, we have to use it as a parameter, as an argument here also. So the question text is this one. So for example, it might be 1 plus 1 colon and space. So now we want to do this is a neat way of actually writing conditionals in Python. So you don't need multiple lines for an if else conditional. It's simple. For example, now we want to return 1 if the user's response is equal to the answer, uh, question answer. Let's actually say user answer, and let's import the question answer as a parameter here. So if the user answer is equals the question's answer, so if the user gets the answer correct, uh, we want to return 1. We can follow this by saying else 0, meaning if you read this, it's very descriptive. Return 1 if user answer equals question answer, else 0, else return 0. Return 1 if this is correct, if it's not, return 0. So this is all what the handle question does. For each question, when we loop through the questions, for each question we want to say result plus equals handle questioning, which we should import it from here. So we say get questions handle questioning. So now we are importing both of them, and so for each question we are passing it the question text, which is question text, and question answer. Okay, so we are passing both of these, and for each question it will evaluate the user's input and it will return the results. Now if we check if everything's working fine, so 1 plus 1, we should say 2, 3, 4. Okay, great. So everything internally is working fine, but we are not actually displaying the result. We want to display the result to the user. So that's another part. So we should create a function called show result. And of course, we have to create that file here, show result.py, def show results. And also we have to add it to our export stack, right? So from dot show results import show results, and as you can see our stack is increasing, our project is becoming more complex, and we are making this code beautiful because we are modularizing everything, and one file does one thing, and we don't have any bloated 1000 line files. So this is how code should be written most of the time. This is the principles of the design pattern, which talks about modularizing your code. And as I've spoken earlier, I'm using the design pattern called dependency injection. So search for it and you'll find many useful videos. Now that we have our show result here, let's import that here. Show results. So we've added it here so that we can access it here directly from the lib. Now, what does the show result actually does? Uh, so we need to display a result. So previously we've been displaying 3 or 2 or 1 as the result, but now we want to use it in a percentage value. We want to calculate a percentage value so that we get an actually valid percentage result. So how can we do that? First, we're going to be calling this the display result. The actual result is stored, but we are using a display result just to make it easier for the user to understand. And calculate results, which is a function that we're going to be using in order to work with display result with percentage values. So we're going to be changing the 3 into a percentage, the 2 into percentage, and 1 into a percentage. So it's simple. We need to create that file, of course. Here's the py calculates results. So how does this work? So in math, so you can do this in Python to create a multi-line comment, just 3 uh, double quotes. So in math, you have learned about crisscrossing to find a result, right? So basically, it's just saying if for example, if we have 3 questions, actually, if the question's length equals 100. So if the user gets the same value as the question's length, for example, if there are 3 questions, if the user gets 3, that means he gets 100. So if the user gets the results, so whatever results the user gets, how much is the display results? So we can say if, for example, 3 equals 100 and the user gets 2, right? So 2 equals how much? How much is displayed in the display result? So I'm going to keep that comment because this part is not really readable. I'm going to keep this comment and say calculate results. Actually, it's a calculated result equals 100 times result, because crisscrossing here 100 by results, questions length by display length. We can just pass in the result here, and here we have also to pass in the result, meaning we need the result here. So meaning here also we need the result. I know it might seem overwhelming, but we're basically uh, importing the result from the main to the show result, and from the show result we are giving it as a parameter to the calculate result, and here we are actually extracting it and using it. So by the way, we need to import this, right? So from dots calculate results, import calculate result. So now uh, we have to divide this by questions length, right? So here also, so after multiplying this 2, we have to divide it. So this is basic maths, and I'm not going to be explaining this, but this is crisscrossing in math. So it's basically, you don't need to know to be like a math expert to be a good programmer, but a solid understanding of mathematical concepts could go a long way. So we also need the questions length to passed in, right? Meaning we have to do this. So questions length. We don't actually have the questions length here. Okay, questions length. We do have it. Let's just change the name. Now we have everything we need. So we have calculated the result into a percentage value. Now we have to return it. The reason I don't just say return this, the reason I don't do like that is because I want to be clear what we're actually returning. So we are returning the calculated result. So it's good practice that you make your code as readable as possible, and I find this returning just this piece here to be not the most readable technique for writing your code. So we have displayable results, which we're getting from the calculate results function. And finally, we just want to show it, right? So say print again, to make it a template, we start with the F. Then we say you scored uh, display results percent. So if the user gets all questions correct, it should say you scored 100%. So now let's save it, and I think we are finished now. The only thing left is actually for us to test our code and make it work if there are any errors. So let's start. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. Okay, you scored 100%. Now, what if we say 1 plus 1 is 0, 0, 0? You scored 0%. 2, 3, but 5. You scored this percent. So, as you can see, we have created a production ready application. So if you remember when we started the video, we have created a simple application. Now this uh, this full application here, it doesn't have uh, it might be more complex, but it doesn't have more features. Just a bit more features like displaying a percentage value. So it doesn't have much additional features, but it is actually production ready, meaning this is scalable, it is readable, it is modular, and this code could be deployed and used in an application without you having to worry about it failing. Because if some part fails, you could test each function individually and find the problem. Uh, this is also better for unit testing. If you want to add a new feature, just come to the lib folder and add a new file. Actually, you most of the time you add folders. We just did without folders because it's actually a simple example, and folders would be too much for this, I think. So just add a new file and integrate it where it should. For example, in the main, or in maybe you want to show color based on what the user actually scored. So below 50%, you want to show red text, above maybe green. So this is for you to decide, for you to make the decisions on, and for you to learn by adding more features. So I advise you to take this code that we wrote today and make it better, make it your own. Learn from it, make mistakes on it, and grow as a developer. So I really hope you did enjoy. Uh, I will continue making topics on advanced programming. I really hope you liked today's video. Yeah, until the next time we meet, goodbye.